Hello students and welcome to the series of queue. As in previous lecture we have discussed the basic concept of queue, what is circular queue, what is definition of queue, and what are the different pointers used or what are the different concepts used in a queue that we have studied in a previous lecture. Now in this lecture we are going to discuss how to insert an element in queue with the help of an algorithm. So as we know that in the previous lecture we have discussed the concept of front and rear. So basically front is the pointer which hold the location of first element in queue, whereas rear hold the location of last element in queue. So here in this algorithm I have used two pointers, front and rear, which hold the value 1, and front hold the value 1 and rear hold the value n. What is this n means? So n is nothing but it is a maximum length of queue. So n is the maximum length of queue. Again we have used one name, that is queue. Queue, it is the name of array, and again we have another, that is item. What item is? It indicates or it holds the element which is to be inserted in queue. Okay, so these are the different terms we have used in this algorithm. So front, rear, okay, hold the location of front and rear element respectively, and maximum length of an array. Q is the name of array. Item, it is a variable which hold the element which is to be inserted in queue. Okay, so these are the terms which I have used in this algorithm. So let's discuss how to insert an element with the help of algorithm. So while inserting any element in queue, we have to consider different possibilities, right? So suppose we have to insert anything in queue. First, what we have to check, that we have to check whether space is available or not in queue. So again, to check that, again we have to consider different possibilities. So let's discuss possibilities for this. Okay, so first possibility that I have written over here, if front is equals to 1 and rear is equals to n. What it means? Suppose I am having one queue, okay, of this size 4. So I will give the indexing 1, 2, 3 and 4. So here in this case value of n is nothing but it is 4. This is the name of my array, that is queue. So now in this case initially my queue is empty. Now if I suppose I will start inserting element one by one. So suppose I will add first A, then B, then I will add C, and lastly I will add the value D. Okay, so in this case my front is equals to 1 because it holds the location of first element, that is A, so it is 1, and rear will hold the location of last element, that is it hold the location of last element D, that is rear is equals to 4, that is it is n. So as we have written over here, value of n is 4. So front is equals to 1 and rear is equals to n. What it means? My queue is full. So this is a condition of my queue is full. Okay, so this is the first condition we have to check while inserting any element in queue. So I hope you understand why I have written this, front is equals to 1 and rear is equals to n. So this is the first condition. And second, what we have checked, or second possibility is there, that is front is equals to rear plus 1. So for this, let's discuss the concept. So again, I am having one queue. As of now, just consider total. Okay, let's stick with the 4. So this is my queue having 4 elements. Now as I said initially, queue is empty. So my front and rear both are equal to 0, right? So now I will add one element A. So just consider this as a circular queue, right? So this is my circular queue. Okay, so instead of writing, I will draw the another diagram. So which is again circular. So same, I am representing in circular format, right? Nothing different. So same 4 elements. Okay. So initially front and rear both are 0. So just consider the same. So I will add element A. One element is there. So my only one element is there. So front and rear both are 1. Then as I said, insertion takes place from rear end. So when I add one element, I have to increase my rear by 1. So rear becomes 2. Front is 1, rear 2. Then I will add C. Okay, so rear become 3. Then I will add D. Rear becomes 4. So front is and rear is 4. Now suppose I remove one element, right? So I will remove, as of now, just consider I will remove A. So deletion takes place from front end only. So by default I have to remove A. So after removing A, my front will, I have to increase my front by 1. So my front will point to second location. So my front will point over here, rear will point over here. Now I will add one more element in this queue. So as this is a circular queue, after 4, what is there? 1. So what I have to do? I have to point rear to the first location, and I will add one more element in this queue, that is E. So in this case, my rear will point to the first location and front will point to the second location. So if we check in this case, okay, my queue is full, right? Total 4 elements are there. Front is pointing to the B, then C, then D and E. Total 4 elements are there. Front is equals to 2 and rear is equals to 1. Okay, I hope you understand. And we have already discussed this same in previous lecture also. So it is quite easy to understand this concept to you. So in this case, my front is equals to 2 and rear is equals to 1. So but in this case also my queue is full. So how to check or how to write this condition for this case? Right, my queue is full. So I will write simple, front is equals to rear plus 1. Rear is 1 plus 1, I will get value 2. It is right. It is 2. So when front is equals to rear plus 1, it indicates my queue is full. So to check whether queue is full or not, we have to check the two possibilities. That is, first possibility is over here, that I have written off. If front is equals to 1 and rear is equals to n, sorry, that is my first possibility is over here. That is, front is equals to 1 and rear is equals to n. It means that queue is full. Or second possibility is there, that is, if front is equals to rear plus 1, it also indicates my queue is full. So while inserting any element in queue, we have to check these two conditions we have to check the two conditions to check whether queue is full or not. So I hope you understand why I have written this first step. So simple, when front is equals to 1 and rear is equals to n, or when front is equals to rear plus 1, if any one of these two conditions satisfies, it indicates that my queue is full. So there is no space available to insert any element in queue. So simply I will simply write overflow. That is, my queue is already full, will not insert any element, or it is not possible to insert any element in queue. So I will simply write overflow and I will exit from an algorithm. So I hope you understand why I have written this first condition. Okay. So if suppose my queue is not full, then what I have to do? Then I have to check, or I have sorry. So again, if my queue is not full, then again I have different possibilities to insert an element in queue. So what are different possibilities? So just we'll go through different possibilities for the same. So as now my queue is not full, so just consider different possibilities. So I will start with the first possibility. So this is my queue. total 4 elements are there. So initially in this case, okay, so this is my first possibility, right? So in this case, my front, okay, no single element is present over here, so my front is equals to 0 and rear is also equals to 0. Now suppose I want to insert one element in this queue. So what I have to do? So to insert, by default I will insert element at this location. So to insert that, I have to increase the value of front by 1 because sorry, I have to increase the value of front as well as rear by 1. So what I will do, I will simply increase the front by 1. So front becomes front plus 1, or I will directly simply set as it is initially 0. So I will simply set front is equals to 1 and rear is equals to 1. Okay, so both front and rear will point to this location. So this is the first possibility, that when my queue is empty. So in that case, I will simply check the condition. If front is equals to null, it indicates my queue is empty. So if this condition satisfies, what I will do, I will simply set front is equals to 1 and rear is equals to 1. Right. If this is the first property, if this is also not there, this possibility is also not there, then we will check the second possibility. What second possibility is there? So I will draw the diagram. So instead of drawing this, we just consider this as a circular. Remember, we are considering this as a circular queue. Okay. So this is the first, second, third and fourth location, right? So in this case, suppose my front is over here and rear is over here. So B, C and D. Okay, so in this case, if we look over here, okay, one space is present over here, or one space is available to insert an element in queue. So now I have to insert this element. So in this case, my front is equals to 2 and rear is equals to 4. Okay, 4 means it is equals to n. That is, last element is present at the last location of an queue. So when rear is equals to n and I have to insert an element in queue, okay, in case of circular queue, what I will do, I will simply set this rear to the location 1. So when when rear is equals to n and space is available, then what I will do, I will simply set rear to the first location that I have shown over here. Okay, this is the second possibility, and again we are having the third possibility. That is, what third possibility we are having? It is simple. Okay, I will draw the circular only. Okay, so I am having two elements A and B. So 1, 2, 3 and 4. My front will point to the first element present in queue and rear will point to the last element in queue. So in this case, this is a third possibility. Okay, so what in this case I will do, so simply to insert, as space is available to insert an element in queue. So in this case, to insert an element in queue, what I have to do, I have to simply increase the value of rear by 1. So in this case, I will simply increase rear is equals to rear plus 1. Okay, so this is third possibility. So set rear is equals to rear plus 1. Okay, so after setting these values, what I have to do, I have to simply insert, what I have to do, I have to simply insert Q of rear is equals to item. As I said, item is the variable which hold the element which is to be inserted in Q. Right? So these are the different possibilities we have considered while writing an algorithm. So just consider one simple example, and I will explain the same by considering one simple example. So I hope you understand these basic steps, why I have written all these steps. Right. So just consider as of now. So in this case, my front is equals to 1 because it holds the location of first location, and rear is equals to 3. Okay, so I will consider this example. So let's go through this algorithm. So we'll check first step. If front is equals to 1 and rear is equals to n. So here in this case n is equals to 4. So here condition is that front is equals to 1 and rear is equals to n. But in this case front is equals to 1 and rear is equals to 3. Value of n is equals to 4. So this condition is not satisfied. Then we'll go for next condition. If front is equals to rear plus 1. Front is equals to 1 and we'll get rear plus 1, 3 plus 1, 4. So again this condition is also not satisfied. It means that there is a space available for element to there is space available in Q to insert an element. So both conditions are not satisfied. This means our Q is not full. So instead of going for overflow condition, we'll go to the second step. So what in the second step, we'll check if front is equals to null. Whether front is null? No. Front is not null. So if this condition is not satisfied, so if is not true, then we'll go for else. So in else we have another condition. If rear is equals to n, we'll check rear. Value of rear is 3 and value of n is equals to 4. So this condition is also not satisfied. So this condition is also false. So as I said, if condition is false, then we'll go for else. So again in this else we have if else. So this if is not satisfied, then we'll directly go to the else condition, and in else we don't have any condition. Okay, so directly we have to follow this procedure. We have to set rear is equals to rear plus 1. So here we'll set rear is equals to rear plus 1. So rear is equals to rear plus 1. So here value of rear is 3 plus 1 equals to 4. So now my value of rear becomes 4. Okay, so after this what we have Q is equals to rear. So sorry, Q of rear is equals to item. So as of now consider, as I said, item is the variable which hold the element which is to be inserted in Q. So here in this case consider item is equals to D. So we have to insert D in this Q. So in this case, in this step, what we have to do, set Q of rear is equals to item. So Q means this array. So Q of rear, value of rear is 4, is equals to item, and value of item is D. So what we have to do, we have to insert D in the fourth location. So we'll simply insert D in the fourth location at this step. And after that what we have simply exit. Right. So when we exit from the loop, what we have done, we have added one element in the Q. Okay, so in this way we can add element in Q. So just remember that while writing an algorithm we have to consider all the possibilities. So we'll go through this algorithm. So in this algorithm, first step is to check whether there is a space available or not in Q. Okay, So if this any one of these two conditions, so this is the first condition. Remember, this one is first condition, which is connected with the help of and this is second condition. If any one of these condition is satisfied, it means that your Q, remember in this case we have considered Q as a circular Q. So if any one of these two condition is satisfied, it means there is no space available in Q to insert new element. So we'll simply write overflow and we'll exit from the loop. Okay. And in the next step, if first step is not satisfied, it means that there is space available, and accordingly we have checked different possibilities in the second step, and accordingly we have made changes, and in the second last step we have inserted one element in Q, and in the last step we have exit from the loop. So I hope you understand how I have inserted one element in Q. Okay, so we'll stop over here, and in the next lecture we'll discuss how to delete an element from Q. Thank you.